Hi, let's take a look at your MT9 final affirmation. If you have a parabola in the form of the vertex form, it's y equals x minus h of quantity squared plus k. A is your dilation. That is, if A is greater than greater than 1, the absolute value of A is greater than 1, I should say. That tells you your parabola is going to be thinner. If the absolute value of A is less than 1, that tells you your parabola is going to be wider. If A is less than 0, you're going to flip the parabola over the x-axis. Now, H is your horizontal translation. You got that mixed up on this one. Notice it's x minus h. So if you're minusing, you're going to go to the right. If you're subtracting, you go to the left. It's kind of backwards. K is your vertical translation. It moves the graph up and down. Notice it's plus k, so that tells you it follows the same order. That is, if it's positive, you move it up. If it's negative, you move it down. So on this question, on part A, notice we're adding 3 to x squared. So that's k. So we're going to move our graph up 3. You moved it to the right. You got those mixed up. So I should have gone up 3 and then drawn your parabola. Now when you see x plus 5, I want to write that as x minus h. So it's x minus negative 5 squared. So that tells me we're going to be moving this to the left 5. I don't know what you did there to get that one. So we should have gone to the left 5, and then we would have had our parabola. And that's the transformations. We'll use it a bunch on this test. On this question, we want to solve for x. I don't know what you did with the x minus 2 squared. You can't distribute the 2 across a minus sign. X minus 2 squared is the same thing as x minus 2 times x minus 2. We have to double distribute that. We have to take the x and distribute it. So we get x squared minus 2x. And then I'm going to distribute the negative 2 inside the parentheses. So we get negative 2x plus 4, because a negative times a negative is a positive. We simplify the left side, and we get x squared minus 4x plus 4 equals, now the right side you have 2x squared plus 3x plus 10. If you have a quadratic, that is, you have a squared term and a linear term, an x squared and an x, you have to make your equation equal to 0 before you can solve it. So that's what we're going to do. And I always like to move the smaller squared term. I like to keep my leading coefficient positive. So what we're going to do is we're going to subtract x squared from both sides because it's a positive x squared. Notice x squared minus x squared, that makes 0. On the right side, 2x squared minus x squared, that's positive 1x squared. Then we're going to add 4x to both sides. And notice, once again, the 4x's, they make 0 on the left side. On the right side, 3 plus 4 is 7x. And then finally, we'll subtract 4 from both sides. So we end up with 0 on the left side. X squared plus 7x, 10 minus 4 is a positive 6. Now, you could solve this by completing the square or factoring. I always try to factor it unless I know I can't factor it. So I'm looking for two numbers that multiply to 6 and add to 7. This is what we did in chapter 8. So those two numbers would be 6 and 1, wouldn't they? Because 6 times 1 is 6. 6 plus 1 is 7. So we're going to say 0 equals x plus 6 and x plus 1. Now we use the zero product property to say x plus 6 equals 0 or x plus 1 equals 0. Well, what do you have to add to 6 to make 0? Well, you get negative 6. What do you have to add to 1 to get 0? So you get x equals negative 1. On Alex, you'll type in x equals negative 6 comma negative 1. And that's what you have to do in that problem. Okay, on this problem, a couple things. Number 1, if you add 3 to both sides, there's no v on the 3. You can't combine these. So what we're going to do is, we know it's a quadratic. No matter how I solve it, I'm going to move the 10 to the other side. Well, I'm going to add 10v to the other side. There are no like terms here. So we get 3v squared plus 10v plus 3 equals 0. Now I'm going to solve this either by completing the square or factoring it. Like I said in the last problem, I always try to factor first. If I can't factor, then I'll complete the square. So, just like we did in chapter 8, when I factor a quadratic with a leading coefficient, I multiply the leading coefficient, the constant. 3 times 3 is 9. I want to find two numbers that multiply to 9, but they add to 10. Well, that would be 9 and 1, because 9 times 1 is 9, 9 plus 1 is 10. Instead of writing 10v, I'm going to write 9v and 1v. Now I'm going to factor just the first two terms. My v kind of looks like a u there. Sorry about that. Well, what goes into both of them? Well, 3v goes into both terms. So v plus 3 would be what's left over when I factor out the 3. Now I look at the next two terms. And you could logically say, hey, nothing goes into both of those. But remember, 1 goes into everything. So I'll say plus 1 v plus 3. Notice my parentheses are the same, aren't they? So I can factor those parentheses out. So I get v plus 3. Second parenthesis is what's left over, which would be 3v plus 1 equals 0. At this point, we're going to use the zero product property. So we're going to say v plus 3 equals 0, or 3v plus 1 equals 0. Well, in the first case, what number do you add to 3 to make it 0? Well, that would be negative 3. In the second problem, we've got a two-step equation, so I'm going to subtract 1 from both sides first. So then we get 3v equals negative 1. Then I'll divide both sides by 3 to get v by itself, so v equals negative 1/3. When you type this answer into Alex, you're going to say v equals negative 3 comma negative 1/3. And that's your answer. Now in the next question, it's backwards. I told you the zeros. I want you to tell me the function. So what we're going to do is we'll start here. We know our answer. I'll use x. So x equals negative 4, or x equals negative 5. Then I want to make them equal to 0 so I can use the zero product property. So I think what I'll do is I'll add 4 to both sides. So then we get x plus 4 equals 0. Over on the right-hand side, we'll add 5 to both sides. X plus 5 equals 0. At this point, we'll use the zero product property. So x plus 4 times x plus 5 equals 0. Well, let's do our double distribute. Let's distribute the x to both those. So we get x squared plus 5x. Let's distribute the 4 to both sides, to the parentheses. So we get plus 4x plus 20 equals 0. Now, combine our like terms. X squared plus 9x plus 20 equals 0. Instead of using 0, I think I'll write f of x. So f of x equals x squared plus 9x plus 20. That would be your quadratic that has zeros at -4 and -5. We're going to graph this parabola. And I think what happened is on this one, when I looked at your work, you only plotted 4 points. So you didn't get a parabola. Let's make sure you did this right, because I can't tell from the work because I don't see all the work, but I do see the table. So x equals -b over 2a. Remember, the number in front of x squared, your leading coefficient, that's a. The coefficient, your linear term, is b, and then the constant is c. So we're going to do -b over 2a. So we're going to say the opposite of 18 divided by 2 times 3. Well, then we get the opposite of 18 divided by 6. -18 divided by 6 is -3. You had that in your table. -3. That looks good. The only thing is that's your vertex, so you want that in the middle of your table. Maybe you just use the fact that you knew it was symmetric. That would explain it too. So we got -3, and I'll have a couple numbers to the left and the right because I want 2 on each side. So I'll go -2, -1, -4, -5. Let's start by finding the value when x is -3, because that's my vertex. So I'm going to copy the problem down here so I don't have to flip it back and forth all the time. So it's 3x squared plus 18x plus 21. So now we're going to do -3. So we're going to say 3 times -3 squared plus 18 times -3 plus 21. Well, -3 squared is +9. So it's 3 times 9 plus 18 times -3 plus 21. 3 times 9 is 27. 18 times -3, that's -54. So I'll say -54 plus 21. Well, 27 minus 54, that's -27, plus 21, that's -6. Notice you had that right. So I'm going to plot this. I'm going to go -3 and -6. Now, let's do another one. Let's do -2. So I have 3 times -2 squared plus 18 times -2 plus 21. Well, -2 squared is +4. 18 times, oh, I'll do that the next line. I like to do the exponents just first. 3 times 4 is 12, minus 36 plus 21. Well, 12 plus 21, I like to add them first. You get 33. Minus 36 is -3. So when you're at -2, you're going to be at -3. Since it's symmetric, we know -4 is at -3, so let's plot those 2 points. So -2 is at -3, and -4 is at -3 also. Finally, let's do -1. So we're going to say 3 times negative 1 squared plus 18 times negative 1 plus 21. Well, negative 1 squared is positive 1. Like 21 looks kind of bad there. Let me fix that. 21. Well, 3 times 1 is 3. 18 times negative 1 is negative 18 plus 21. I'll combine my positives first. So 3 plus 21 is 24. (24) minus 18 is positive 6. So I know negative 1 is going to be at 6. Since it's symmetric, so it will be negative 5. So negative 1, I'm going to be at positive 6. And then negative 5 is also going to be at positive 6. Then, if you click your parabola or your graphing key, it'll put that parabola in for you, and that would have been your answer. Now, I want to find the zeros of this quadratic function. Once again, no, you can't just subtract 8 from 12. That doesn't make any sense, or how you get 2x. We replace y with 0. So 0 equals x squared plus 8x plus 12. Now, can I factor this? Can I find two numbers that multiply to 12 but add to 8? Well, those would be 6 and 2, wouldn't they? 6 times 2 is 12. 6 plus 2 is 8. So we're going to say 0 equals x plus 6 and x plus 2. Now we use our zero product property. We're going to say x plus 6 equals 0 or x plus 2 equals 0. We minus 6 from both sides. So x equals negative 6. You probably could have done that in your head. Or, what number do you add to 2 to get 0? Well, you get negative 2. And since on Alex, they're going to have you write with a comma, x equals negative 6, comma, negative 2, because you have two answers. Okay, now this one is we want to complete the square. I didn't see any work for this one, though. When you complete the square, you want all your variables on one side and all the numbers in the opposite side. So the first thing we're going to do, we're going to add 2 to both sides. So we get x squared minus 2x, leave a space, equals 2. Now I look at my coefficient of my x term, I'm going to take half of that. So I go over to the side here. I'm going to take 1/2 of negative 2, and I'm going to square that. Well, half of negative 2 is negative 1. I square that. I get positive 1. So I add 1 to both sides. Now I want to factor it. So if I factor x squared minus 2x plus 1, I made it a perfect square. That's what we call it, completing the square. So I make this a perfect square. The square root of x squared is x. In this case, I'm going to use the square root of 1 is negative 1, because your middle term is minus. And it's not squared. I almost forgot that. X minus 1 squared equals 3. That's what you're going to type in for your first form. So you're going to say, hey, x minus 1, the quantity squared, that equals to 3. Now let's solve it. We're going to square root both sides. The square and square root cancel because remember, the inverse operation is square and is square root, so you get x minus 1 equals plus or minus the square root of 3. So to solve for x, we add 1 to both sides. The exact answer is x equals 1 plus or minus the square root of 3. But we're told to round our answer to the nearest hundredth. So we're going to use a calculator here. We're going to take 1 plus the square root of 3. So I go 1 plus the square root of 3. I get 2.73 is one of our answers. So x equals 2.73, comma, and let's take 1 minus the square root of 3. And you get negative 0.73. There's your answer for that one. Okay, this translation, it's x minus 3. So we're going to go to the right 3. And it's a vertical shift up, and up 1. So I'm going to take my translation. I'm going to go to the right 3 and up 1. There's going to be the vertex of our new problem. You went to the right 5 for some reason. And then just slide your parabola over there. Okay, function 1. I need to find the vertex. So you do x equals the opposite of b over 2a. Remember, on function 1, a is 3, b is 12, c is 13. You won't use c on this problem, but we'll write it down anyway. So it's the opposite of 12 over 2 times 3. Simplify that so I get negative 12 over 6, or negative 2. So x is negative 2. Now I want to find f of negative 2, to find the y-coordinate. Well, that'll be 3 times negative 2 squared. And that'll be plus 12 times negative 3. And then we'll say plus 13. So let's simplify that. We get 3 times 4 plus 12 times negative 3 plus 13. 3 times 4 is 12. And then 12 times negative 3 is negative 36 plus 13. So 12 plus 13, well, that's 25. 25 minus 36 is negative 11. So that is the vertex, that's the y-coordinate of this point. Now if we look at function 2, that one's a lot easier to see the vertex is, and you just look up right here. It's over 4 and up 3. Which function has a smaller minimum value? Well, which one has the y value that's smaller? Which is smaller, negative 11 or 3? So function 1 has a smaller minimum value. What is that? Well, that's negative 11. That's how you would do that problem. Okay, we want to solve this equation by graphing. So we're going to graph the equation and look where it crosses the x-axis. And they gave you the directions. You got to follow the directions. I want you to plot the vertex and then 4 additional points, 2 on each side of the vertex. So the first thing we're going to do on this question, let's find the vertex. So x equals negative b over 2a. A is 1 in this problem, and b is negative 10, and c is 24. So I'm going to do the opposite of negative 10 over 2 times 1. So that's 10 over 2, which is 5. So what I'm going to do is I'm going to make my table now, my XY table. And I'm going to go 5, I'll go 6 and 7 and 4 and 3. Now I'm going to find the value of my vertex. So now I'm going to do x squared minus 10x plus 24. I'm going to find when x is 5. So I'm going to go 5 squared minus 10 times 5 plus 24. So I get 25 minus 50 plus 24. 25 plus 24 is 49 minus 1, or minus 50, I'm sorry, my brain went to the answer, which is negative 1. So I go over 5 and I go down 1. Now, let's find the value when x is 4. So we're going to say 4 squared minus 10 times 4 plus 24. So we get 16 minus 40 plus 24. Well, 16 plus 24 is 40. Minus 40, that gives me 0. And since I know it's a parabola, I know it's symmetric. So when x is 4, you get 0, and when x is 6, you get 0. Finally, let's do it when x is 3. So I'm going to say 3 squared minus 10 times 3 plus 24. Well, that's 9 minus 10 times 3 plus 24, or 9 minus 30 plus 24. 9 plus 24, well, that's 33. Minus 30, that gives us 3. So I know when x is 3, y is 3. When x is 7, y is 3, because I know it's symmetric. Now you can draw your parabola. Your zeros are when x is 0. We could have solved this a lot sooner, but we had to graph the whole thing. So what value of x is 0? Well, we look at our table. When x equals 4, you're at 0. When x equals 6. So what you should have typed in here was x equals 4, 6, because when it crosses the x-axis, that's your solution. Okay, let's take a look at this problem. It says a medical equipment industry manufactures x-ray machines. The unit cost, or the cost in dollars to make each x-ray machine, depends on the number of machines made. If x machines are made, then the unit cost is given by the function 0.4x squared minus 96x plus 16,541. We want to find the minimum cost. Well, if we look at this, this is going to be a parabola, isn't it? It's going to be a happy parabola. So your minimum cost is going to be your vertex. So we need to find the vertex of this problem. So we know x equals negative b over 2a. So a is 0.4. B is negative 96, and C is 16,541. So we're going to say the opposite of negative 96 over 2 times 0.4. So that's 96 divided by 0.8. Well, let's take our calculator. Let's take 96 divided by 0.8. And we get 120. So if you make 120 machines, that will be the lowest cost because of labor and the cost of the machines that you could make. That's not the answer. I didn't ask for how many machines you're going to make. I want to know what the minimum cost is. So now what we're going to do is we're going to replace x with 120. In other words, I want to find C of 120. So I'm going to say 0.04 times 120 squared minus 96 times 120 plus 16,541. Let's use a calculator. So I'm going to take 0.4 times 120 squared And then minus 96 times 120. And then plus 16,541. I'm going to double check, make sure I got those numbers right. Yep. And there's our solution. Did I do something wrong? Oh, minus 96. Whoa. I was going to say I got a negative answer. That's not right. It was minus 96. So we get 10,781. So the minimum cost to make each machine is 10,781. Now, and they sell them, I bet you they sell them for at least 25,000. So, because it costs 10,000 just to make them. Okay, on this question, part A is correct. You got, when that parabola opens down, you know it's negative. When the parabola opens up, you know it's positive. However, the next two, choose the one that's closest to 0. Closest to 0 means that is going to be the widest parabola. So I look at my parabolas. Which ones are the widest? Well, that would be choice C, wouldn't it? And you put down B. You put down, looks like the thinnest one. Choose the coefficient with the greatest value. Well, the greatest value is going to be positive, so it's going to open up, and it'll be the thinnest. So we're only looking at two choices here. Since it opens up, I'm choosing between C and D. Which one is wider? Well, I should say which one is narrower, because that's what we're looking for. Well, that would be choice D, wouldn't it? You had that one kind of backwards there. Okay, last question, I think. Do the same thing. There's a number in front, so that does change how the parabola, this is going to be a thinner parabola. But we know the vertex of this parabola because it's in vertex form. It's going to be x minus h, which is 1, and k is going to be negative 4. So when you make your xy table, you're going to put 1 and negative 4 in your table. I'll have a couple numbers to the right and a couple numbers to the left. Now let's put 2 in for x. So I've got 3 times x minus 1, the quantity squared, minus 4. I'm going to replace x with 2. So I'm going to say 3 times 2 minus 1 squared minus 4. Well, 2 minus 1, well, that's 1. 1 squared, that's 1. Multiply by 3. 3 minus 4 is negative 1. So we know when x is negative 2, y is negative 1, and we know it's symmetric, so I know when x is 0, y is negative 1. So let's plot those. First, we're at 1 and negative 4. And then we're at 0 and negative 1. Or 2 and negative 1. Finally, let's do one more. Let's find when x is 3. So I'm going to go 3 times 3 minus 1 squared minus 4. 3 minus 1 is 2. 2 squared is 4. 3 times 4 is 12. Minus 4 is 8. So when you're at negative 1, we're going to be up at 8. And when we're at positive 3, we're going to be up at 8. Then click on your graph and you should get a parabola. Make sure you do all 5 points. I noticed that on your test, at least on one of the questions, you should have gotten that right, but you only did 4 points, so it counted it wrong. Okay, The redo should be open for you. Go ahead and redo it.